Contrast agent. As we know, the discovery of the X-ray, it was in 1895. After this discovery, after 3 years of discovery in 1898, the physiologist Bradford Cannon, he used these X-ray along with the some material, and that was bismuth meal. He was a physiologist. He studied the physiology of the upper GIT of a cat with the help of these X-ray and bismuth meal. So at that time, the contrast agent used was bismuth meal, and X-ray were used for the contrast radiography. But this bismuth is having atomic number 83. Why these atomic numbers are important to remember? Because in contrast radiography, we use agent with atomic number more than 50. Bismuth was having atomic number 83, but the problem with the bismuth was its toxicity. Bismuth salts are highly toxic. So this bismuth, which was the first material to be used as a contrast agent by the Walter Cannon, this was toxic, and later on it was replaced by the safer one, barium sulfate, in 1910. This barium sulfate was used orally because of its property that is insoluble. It is insoluble, that's why it is not used as IV agent. So we used it as oral agent. So because of its insoluble property, we can use barium only for GIT. So barium studies are done for the GIT, contrast radiography. So this barium, it was not replaced along with this insoluble material that we are using these days. Along with this, what they have discovered, they discovered some intravenous agent, some water soluble agent like iodine, having atomic number 53. So iodine is a soluble, so the one more advantage with this iodine is we can give intravenously. These iodine agent, as per the discovery, initially the oldest or conventional one, they were the high osmolar contrast media. They were having high osmolality. Then they discovered low osmolar. Now recently, the latest concept is iso-osmolar. Osmolarity should be similar to your plasma, that is 290 to 300. So these are the safest one because they have the osmolality just equal to your plasma. So this was the sequence how we came from the bismuth to today's iodine water soluble contrast agent. So first was bismuth, it was toxic, so replaced with barium sulfate. But barium sulfate is used only for GIT. It is insoluble. So we discovered something new like iodine agent. They are water soluble, we can inject them. And these were also the oldest one. They were having high osmolality. So the clinical implication of this osmolality is the nephrotoxicity. High osmolar and low osmolar, they are nephrotoxic. So we came with a new concept, iso-osmolar. These are the safest one. These are the recent one. Only limitation is they are more expensive. So this is how the contrast agent were used after the discovery of the X-ray. So X-ray were discovered in 1895 and these were used in 1898 by the Cannon. He was a physiologist. He used to study the physiology of upper GIT of a cat, dog, and some poultry birds. So with this small history, And the sequence will see contrast agent are of three types. Contrast agent, they are of three types based on where they are used. They may be used as a radio contrast agent. They may be used as radio contrast. Means you can use them in X-ray or CT scan. They may be used in X-ray or CT. Second, USC, ultrasonography. We are using them in the with ultrasonography. These are nothing but small micro bubbles. These are micro bubbles which is having air, some gases, which gas most commonly SF6. Then we have MRI. The contrast agent used is the GD, gadolinium. So these are the techniques and these are the name of the contrast agent. So first we'll see radio contrast agent, where the use of X-ray, we are using X-rays. So these radio contrast agent, as I told you the history, first was bismuth, toxic, so not available. Second was sulfate, can give orally. Iodine can give IV. So in this lecture we'll focus on these two, barium sulfate oral and iodine, that is IV. So radio contrast agent, these may be positive, this may be positive or may be negative. These may be positive or negative. Positive means they are more bright, they are more white than surrounding. If you inject or give orally, they are more whiter, they are more brighter than the surrounding. What is the reason for this? Why they are more white and why they are more bright than the surrounding? The reason is these agent, positive agent, they attenuate X-rays more. They attenuate X-rays more than the surrounding. Next question is why they attenuate more? Attenuation means absorption plus scattering. Why they attenuate more? Because attenuation is directly to atomic number. They have more atomic number, so they attenuate more. They attenuate more, that's why they are more white, more bright than the surrounding. And why they are called negative? Because they cause less bright, less white, or I can say more dark. They are more darker than surrounding. More darker than surrounding. Again, same reason why they are more dark than the surrounding. Reason same, because they attenuate the X-rays less than surrounding. Less than surrounding. Next question, why they attenuate less? Because they have less atomic number. So some attenuate more, some attenuate less. So this depends on atomic number. For example, first agent, that was the bismuth, then we came with barium, then iodine. Positive, there is one requirement This positive agent must have atomic number more than 50. Their atomic number must be more than 50. This is the first requirement. First requirement. And bismuth, which was toxic and replaced, it was filling this requirement 83, 56, and 53. So these are atomic number more than 50. It means they will cause more bright, more white than atomic number is 4 only. Atomic number is 4. So less atomic number, less attenuation. They will give more darker than the sun. So this is the basic why some are positive, why some are negative. Example of positive, yes, indium sulfate, iodine. These are oral, these are iodine. What are the example of negative? Yes, air, CO2, nitrogen, and water. So these four are negative contrast air, CO2, nitrogen gas, and water. Positive are barium sulfate and iodine. So with the positive, we started with bismuth that is not using these days, barium, sulfate, and lead, iodine. First, we'll see barium sulfate. What are the properties of barium sulfate? First, it will attenuate for 56 atomic number. Second property, as I told you, it is insoluble. It is insoluble. Where we are using oil. It is inert, non-toxic. That's why, because it is non-toxic, it is the toxic. It coat the mucosa uniformly. These are the reasons why we are using it for CRP. But contraindication, where not to use, that is perforation of ear. If there is perforation, then barium sulfate will cause peritonitis, severe peritonitis, and granulomatous granulomatous. So granulomatous reaction and peritonitis. Contraindication is perforation of ear. Such cases are there. Perforation of ear, it is contraindicated. Then what to use? We can go for iodine contrast. We can inject those. We have iodine cases. Iodine. So this was about barium sulfate. So barium sulfate is used as we call barium study. It is used for barium study. Barium studies like barium and before barium, let's start with barium. It is used for isotherm and barium that is used for study. That is used for study. and devotee. And last is American. That is called the large letter. After radium sulfate, we study iodinated compound. Iodinated compound is the most difficult to remember. Let's see iodine compound we have. Three chemical compound we have. One is water soluble. One is water soluble. One is water insoluble. They are available as suspension. And one is political. One is political. These are tri-iodinated. Tri-iodinated means they have three iodine. They may be monomer and they may be dimer. Monomer means 3 iodine, dimer means 6 iodine. This is the benzene ring and 30 benzene. So monomer they are tri-iodinated. They have 3 iodine. 1, 2. They are also triad, but they are dimer. They have 6 iodine. Total 6 iodine. So monomer have 3 dimer. They are called tri-iodine. They are water soluble. They are given by iodine. They are more common as these. In case of oil, we have only 3. Why? They repeat required. And the third is iron and dialect. Iron and dialect. In all the 3 cases, both the examples, if you read in sequence, oil is written O by L. In this also O by L. Oil. Here oil. Here also O by and L. So oily compound is their name station. So oily compounds, they may be water soluble, water insoluble suspension, or they may be oily. Out of these 3, these are more commonly used. So next we'll study water soluble tri-iodinated contrast base. So water soluble is tri-iodinated heavy iodine compound. They may be mono and they may be dimer. Monomer may be ionic, monomer may be non-ionic. Similarly, dimer may be ionic, dimer may be non-ionic. So these compounds are they belong to these 4 groups. These 4 groups. Ionic means they will give 2 ions. One cation, one one cation, one cation may be sodium, salt, or magnesium. And cation most commonly uses sodium or magnesium. This priority is your contrast agent. This nitrile having two ions. All that give you two particles in the solution. So they are water soluble. This is the water. In this water, they will give you one and two particles. These are non-ionic. They will remain as one particle only. They will not dissociate even in the metal. Although they are water soluble, they will not dissociate because they are non-ionic. They remain as one particle. Again, diamonds are ionic and non-ionic. They will give two particles in the solution. In the solution, they will give two particles. And non-ionic will give as one particle. They will not dissociate. So with this basic, we will see what is ionic particle ratio. This ionic particle ratio will tell you out of these contrast agents, which is safe, which is not highly active. So the safe or non-safe, orthodoxy or these customers, that will be determined by the iodine particle. Out of iodine particle, I explained here only. Ionic, where it is monomer or anion. Ionic means it will give you two particles. Non-ionic without ions just remain as one particle. Ionic monomer will give you each ionic. Dimer will give you ionic. If we sum up this information, ionic and this particles, this ionic, we will get ionic particles. So before going to ionic particles, we have to know iodine and particle. Iodine is radio opaque. Iodine is radio opaque, means white. If you look at the X-ray, it will look like white color. It is radio opaque. Particle will increase, will give you osmolality. They will increase osmolality. They will increase nephrotoxin. This radio opaque or white pictures, what is the use of using iodine to increase contrast? So what will be an ideal contrast agent? Ideal contrast agent from contrast agent, what we want? We want that it should give more contrast to my end. Along with this drug or this agent should be sent causing less memory. So whatever agent we are using, our requirement should be giving more contrast and giving less memory. It means iodine by particle. More iodine will be needed and less number of particles are needed. Requirement